everyone, so my name is S. Prashanti. I am doing my BTech second year in the stream of Electronics and Communication from Acharya Nagarjuna University, Guntur. So I have done my online internship on embedded systems provided by emertxe Information Technologies. So in this project, I have learned about the introduction of embedded systems and its components and software which are used in this project and pick micro, and specifically we have used the P16F877 microcontroller. So we can implement this project by using the emertxe and the peripheral description, like we are using the LEDs, digital keypad and CCDs, etc. The LEDs, digital keypad and CCD. Finally, I will show you the project demonstration and sample output. So let's going into the brief inside deep intro about this project. So this project explains about the washing machines. So we know washing machines which are used in daily purpose in our homes. So whenever we are washing a glass human by using with our hands, so it will takes more time. So we are spend more time on that. But so for that purpose, instead of human washing, so we are using implemented by using the automatic machine. It can also save the human time. So we washing machines are more important place in modern society. So customers wanted to have fully automatic machines instead of semi-automatic washing machine. So in this project I have built this sample washing machine prototype by using PFF877 microcontroller and coming into the embedded systems. So we know the embedded system is a combination of both hardware and software electronic gadgets to do a specific task. So some of the examples of embedded distance. So generally embedded distance, so we can everywhere in our daily purpose, like microwaves and the ATM machines and the ACs. So there are so many examples of embedded systems. And coming into the washing machines and refrigerators and manufacturing plants in the industrial control and navigation systems in automobile medical device in the every industry there is embedded systems which can implement it. So this is about the brief intro about embedded systems. And coming into the types of systems and coming into the types of embedded systems, and the embedded systems can be classified into the two types, that is based on the performance and functionalities required and the based on performance of microcontroller. So coming into the performance, there are four types of embedded systems there are exist. First one is real time embedded systems. So the name it indicates, so it can specifically perform the any task within a time period. So if it can tear this time period, the automatically the gadget is destroyed. So here the time specific bond is particularly matters. So coming into the examples, we can take the rockets and jets and missiles. So the real time applications which can be used in this type of applications. And coming into the second one, that is network embedded systems. So network embedded systems are used to communication between the one place to another place, one form to another form. So we are using the switches and some hubs in for networking purpose. So here we can implement this type of embedded systems for the communication. Coming to one mobile, so we are using the advanced mobiles nowadays. So we can touch a mobile by using screen. So it can act as a sensors, touch sensor. Not only touch sensors, there are so many sensors and the different types of embroidered components which can be imbued on the mobile. So we can implement the more amount of projects by in the mobile industry also. And coming into the last and stand alone embedded systems, it can take the input and it can process it and we get the output. This is the basic operation of stand alone. Like if we can take the examples, washing machine, refrigerators, microwave, EV. So these are all come under the stand alone. And the second classification is based on the performance of microcontroller. It can classified by three types: small scale, medium and medium scale, sophisticated. So this is about the types of embedded systems. And coming into the next one, the major components which can be used in embedded systems. So I have already said the EM systems are microcontroller or anything, it will take the input and it can process it and we get the output. So in the input side, we will use the different types of sensors, Digital keypads are also using for the input and sensor temperature, sensor humidity, sensor light, sensor IR, sensor different types of sensors for the input, and it can be converted into the analog to digital F by using the different types of force which can be implemented on board coming into the process. After converting into the analog data into digital data, it can perform this some operations by using the CPU. CPU is nothing but we can assume it is a microprocessor and microcontroller, the main operation which will be implemented on this CPU part. So after completion of every processor or any task, so it can be converted into the analog form and it can be in physical form. So here the actuators which can be act as the transducers, not only actuator sensors are also act as a transducers, or which can be converted into the energy one form to another form. Here the actuators we can see the output in physical form like LCD, and we will take the LEDs and the budgets. There are so many actuators which can be see the output and coming into the memory. Two types of memory has exist RAM and R. So random access memory for the general purpose operations used, and the room that is this is a permanent memory. We can store the data in this memory. And FPGA is a field programmable gate array. There are different types of IC chips are used to this IBGA, and this is the basic block diagram of embedded systems. And coming into the next one, pick microcontrollers. So particularly in this project we are using P16F877 microcontroller. So it can be provided by the microchip company. So it is one of the used microcontroller in the industry. So particularly automotive industry is mostly used this microcontroller. And coming into the pin description, it has 40 pins and it consists of a 5 ports in total: port A, port B, port C, port D, and port A, port E. So in the port A it consists of a 6 pin, and port B 8 pins, and port C 8 pins, port D 8 pins, port E 3 pins, and also extra we are using the power supply and the ground and extra pins for each running. And also it can supports the serial communication. For it has a 2 pin transmitter and receiver pin. It can also support the SBI protocol serial parallel interface, and if this clock frequency range between 4 mass to 40 mass. So this is all about the peak microcontroller. And coming into the software which are used in this project, those are PSIMLab and MPX Lab ID and XC9 compiler, PackGenius, Pi. In this PackGenius we have to select particular board by in the PIC simulation lab. So here we can see P6F877, a microcontroller board. We are using this board in this project. And PEAK simulation lab. In the PEAK simulation lab, it is a virtual IDE, virtual software. We can implement our project in virtual way. Here that there are so many types of microcontroller board are provided by these software. Like we can take the ANA MS4. So there are so many boards are provided by the software and the MPX Lab ID. So we use the software for the writing the program and compilation for the PIC16F77 microcontroller. So these are all about the software which are used in this project. And I am coming into the embedded C. So why we are going into the C? Why? Because of it we are taking into the Java, Python, and anything. So its process is very less as compared to the C language. And language is portability, and also it is relative close due to the architecture of microcontroller. That's why still C language is implemented in microcontroller projects. So C is the important for embedded system. Why? Because of its efficiency and probability and low level access. There are so many advantages in C language for implementing the embedded system project. And coming into the main contents in C are data types and variables. So we know the data types. There are different types of data types. Data types are nothing but which type of data we are in using. So I take an example, that is 10 is an integer value. So we can give the integer 10 for the variable. Every value we have to indicate by a variable is nothing but a named memory location. So integer is equal to 10. So whenever we have to show the output on any compiler, any console, we have to only declare the then we will get the output. And coming into the pointers and memory management, so pointers manipulating the memory address and access the hardware registers directly. So by using the pointers, we have to use the address of the pointer. We can declare it and anywhere. And control structures implementing the decisions making logic and the repetitive task. So control structures coming into these types of topics, we are if else and else if added. So these are all the control section, and also loop are also existing in language, that is for loop, do loop, while loop. These are all used to execute the program multiple times. So we can use implemented infinite times. Most of the times the loops used in embedded C. Why? Because of our project can be run so more than 10 years, more than 1 year. So that's why we are using loops. Then coming into the functions of the modulus programming, so functions are used to reusable the code blocks and facilitating the modular software design. And coming to the last topic, that is the preprocessor directors, manipulating the sound source and defer compilation for defining constant and conditional compilation. This is all about the embedded C. I have learned from this internship, and I am coming into the next topic, that is peripheral. So we can take the peripheral like LEDs, LCDs and digital switches and bus badges and the DC motors. Anything, these are all the peripherals which can be implemented in embedded systems project. And coming into the LED, it is a light emitting diode. It is a semiconductor device which can emit the light whenever electric current passes through it. So here we can see that the LED, it consists of two pins, that is positive anode pin and negative cathode pin. So here the positive pin which can be connected to the quad pins of a microcontroller, and the negative pin can be connected to the ground. So LED is an external device which can be connected to the microcontroller port. LEDs we can use commonly for indicating the lights, displays, illumination. So this is all about the LEDs. And the next one is the tactile switch as digital keypad. So we have to use this for the whenever we are pressing this button, so that turn it can be on the state. So whenever we release the switch, it is in the off state. So like we will take the example led by using LED by using the switches. Whenever I will press a switch, the LED is on. Otherwise, I will release the switch, the LED is off. So it's only because of performance of the switch. So whenever I will press this button, the current passes through it, then the LED is on. Otherwise, it will be off. So this is about the digital keypad. And coming to the next one, that is CLCD character, liquid crystal display. So it can be used to display the images of the characters and some extra characters in the LCD display, and it can be operated by the liquid crystal controlled by the electric signal. The main pins in this LCD are VDD and VSS for power supply, and the ground for the control purpose. We are using the RS, RN and enable, and the data lines are D0 to D7 along with the V output pin. Unlock and cathode and anode. Here we can see this LCD. Here the pins in the CLCD all in the arranged in this order. This is all about the CLCD. And the next one is interrupts. So interrupts in microcontroller, these are two types of interrupt. It can be hardware interrupt or software interrupt. Interrupt is nothing but a temporarily suspend the normal program which can be executed the and the specific program whatever we give as input. So for example, I will take the sensor, IR sensor. So whenever the person or light is fall on the sensor, automatically the LED is on. So it can be act as an interrupt. So it can stop the microcontroller program from that state. This is about the interrupt. And the interrupt or external request, the microcontroller unit to stop the processing. These are two types of interrupt. This is hardware and software. And coming into the next one, timers. So timers are used to maintain the time delay in microcontroller, and it can can also generate the time signals bit by bit, and it can implementing the time critical operation. They can be configured to operate in various modes by using the counters and PWM pulse, WLD modulation and capture and compare modes and different types of requirements which can be using these timers. Timers are also offers the future adjustable prescalers and reload values allowing for time grain and control. However, the timing, resolution, and period essential for applications such as motor control, communication, protocol, and real-time systems. So there is about the timer. So now I will show the project about whatever I have implemented in this project. That is a washing machine control. So this is the i6 F877A microcontroller. This is the Pick Genius board. We have to select in this board Pick Genius. So I have already selected and we upload the code, upload and code. I have select this one. Our code is uploaded to this board. We have to press this button for rest. So I have already uploaded the code. So here we can see that is CLCD press key fire of power on the washing machine. So whenever I will press the switch 5, so it can shows the washing programs daily, heavy and white and heavy whites and delicate whites and delicate and eco cottons, and different types of options were available for washing. So I will select the woolens. So after pressing long time the switch, so it will go to the which mode of operation we have to wash our clothes. So I will press this long time. So we have to wait for few seconds because of it will take time. So here we can see that the different types of modes we have to implement it in the water level, that is auto, under the low and medium, and the next one level and medium and high, medium, high and maximum, high and maximum and auto. So I will again long press this auto. I will select this auto mode. I have to again press this button long time. So here we can see that when I watch switch on for the start the washing clothes, and I will press the switch 5, so we can see that our clothes are washing. So we have to stop our clothes washing. So I will press the switch. So here we can see that whenever I will press the switch button, the fan is off. So like the clothes are off washing. So I will press this button. We can see that how it will operate. So the fan is off. So it is in the off position. So again I want to wash my clothes. I have to press the switch fire button. So I will press now. We can see that I will press this, so my clothes are washing. Now where we can see that my fan is running, so we have the wait for the few seconds. I will set the timing 30 seconds. Whenever this timing is completed automatically, my washing machine is stops. It will shows the budget to me, indicates that my washing clothes are completed. So we have already seen the programs are the clothes are completed. It will shows the budget to me. So not only this project, we can also implement that so many projects by using this microcontroller board and the MPX lab ID. So that all about this project. So thanks for MTech so providing this type of internship for me. So thank you. Thank you for giving me this project.